Okay.
Okay, then let's continue with that. So let's have a deeper look into the details. So we start maybe with the Gradle file of the project. So let me close those. It's obvious. So the outer project does not contain directly any source code,
Okay.
just the Gradle setup. And here it's just basic setup using the multi-platform Android because it's used here.
Configuring the
Other thing, yes,
plugins.
settings Gradle. So I'm still also learning Gradle, so I might need to find things. So here you see that the different projects that are included.
Mm-hmm.
So the Android app and the shared part, not iOS because it's not Gradle. But if you would add more projects here for web and so on that also work with Gradle, you can also put them here. Yeah, that's the Android SDK really worth checking. And then the Gradle properties, I guess you know more about this. What this does.
You can configure stuff for Gradle there.
Exactly. So not too exciting. It also comes already with the git ignore. It's also nice, so you don't end up with messing up your project. And that's basically already it from the external thing.
Yeah.
Now, if we check the shared part, which is the most interesting, and look at the structure here. So again, a Gradle file for the shared folder, and then you have 3 folders. So if you check the test checkbox, you would have also test
for each of them.
For each of them, for each of them. And so the setup is that most of the code goes into common main.
Okay.
And sometimes you have code, unfold all of them, that needs to work with platform-specific APIs.
Like?
For example, here it returns the I go here. It returns the either Android or iOS, depending what platform it is running on, and then the version.
Okay.
And that you cannot know in shared. So
yeah,
if it's in theory, this one returns the string Android and this the string iOS. So not even any. For that you don't even need platform-specific APIs, but it's a platform-specific value. Or to get the version, like here on Android, you use a platform-specific API.
Yeah, and I guess stuff like maybe Bluetooth or so.
Yeah, so that would be, so for Bluetooth, I would even go one level, I don't know if down or up. Bluetooth, the actual Bluetooth code I would put inside the iOS app and the Android app.
Okay.
Because Bluetooth is already flaky enough and causes problems if you use it natively in the app.
Okay.
So then routing this through the shared Kotlin part might not be a good idea. Mm-hmm. But what you would do is have maybe like a shared Bluetooth service or something that then has interfaces or connection points to the actual app, where then passes through information. So but that is way advanced and not covered today. Other example for where you would need this, and we go into more details later, is if you want to store a file or something, because then you need to get the correct location where it needs to be stored, and then
that's always specific.
Yes, how you get that. Other example would be to generate a UUID, for example. It's the platform-specific APIs there. Okay. I will go into more detail how that works, how it picks the correct platform and so on. Want to have a quick look in the build Gradle file. So we have the multi-platform Kotlin plugin, obviously Kotlin we need, and this one is there to that the shared part is created as an Android library that then can be linked from the Android app.
Yeah.
And then you specify Android and iOS, how the framework is named for iOS, And then the important part is here, the source sets.
Wow.
Very big. Yeah, maybe I should. But it's fine, I guess.
Yeah, that's fine.
Here you specify the different source sets groups, like I showed here with the Android main, common main, and iOS main. This is basically reflected here. You have the common main, the test thing.
So there's also some source sets that are not currently, there's no directory there at the moment because we don't use them yet. But you could have a different implementation for iOS x64 versus ARM.
I think so. I have not really tried that. I guess so, yeah. So you don't really need it.
Yeah.
So it all falls back to the
iOS main.
Where is it? Don't see it. Yeah, the
big one.
Yeah. And there it declares that all the others depend on that. And yeah, you have the common main. Here you also already see how to add a dependency. It's a test target, the Kotlin test dependency. We will also soon add a dependency to the other source sets. And then you have iOS, Android, and then some configuration for the library.
Yeah.
And this already comes on this and works like this out of the box. There are other plugins that you may need later. One we will add in the next part for serialization, where the I guess it's then for the compiler, right? Needs some more information there to handle that. But there's also a plugin which simplifies the use of coroutines in iOS. That you would also put here. And there's a lot of different dependencies. The important thing is that they need to support Kotlin native, and the if it's a multi-platform dependency, you can add it to the common main, and it automatically is also added to then the platform specific.
Because it comes with both versions, with the Android part and the
yes, and it automatically adds them to the other targets.
Nice.
So you just specify it in the common main, and if you have a platform specific dependency, you specify it in the platform where it's needed.
Okay. Nice.
I think we will also see an example for that. And that's it here. And then the Android app, I think it's a default Android app, so I know not there.
It's a standard Android app.
So you have like your activity and stuff, and again the build Gradle with all the Android specific options. One KMM specific thing is the dependency to the shared project, which is linked here. So you can do that because of this Android library plugin. And then it just is a dependency of the Android app, and you can just use it like a normal library. And for the Android side, that's already basically it, how to use it, because it's a normal library for Android, and you just call the functions as you know it.
I mean, if you want to run it, it's already selected in the top, and you could just hit the green button to start a simulator and run it.
Yes. We'll do this also soon. So for Android devs, it's a no-brainer, I would say, to use it, because it's instead of just extracting your business logic into its own library, which is maybe a good idea anyway, you do it that way, and then you can even share it with iOS. With iOS.
That's really cool.
And most of the popular frameworks already support the multi-platform thing. So
that's really nice.
And I think it's getting more and more, but you have dependency injection, networking, database, and these kind of things.
That's cool.
So quite good. Okay. That's it for the project, and you already said let's run it. So it has two run configurations, one for Android and iOS, and I was really surprised that it's working that nicely for iOS. It might be that you don't have a simulator or emulator set up yet, then you can do it with the device manager, set one up. And same for the iOS app. you may have to create a new iOS application and then select the Xcode project, and the scheme is then automatically filled. How can I remove that? Just press cancel like this. Yeah, and then it ends up like this. And with Android, because it's Android Studio, you can select the emulator here. For iOS, you need to define it here, which one you want to use.
Okay.
Press cancel and then press just the run button. And this brings up the emulator here. Takes some time. Gradle build is running. Creating the library, creating the Android app, and the Android build is faster than the iOS one.
Okay. Is it faster than a normal iOS build, or is it just because it also needs to build the shared library?
It's because it needs to build the shared library, and since you don't have Gradle running all the time there, it then fires up Gradle and compiles everything and so on and so on. But it should now start and says hello Android 33.
Nice.
So 33. Sorry, switched to German.
I didn't even notice.
No one noticed. Yeah. So this works fine. And for iOS, just put iOS, run the button. Now you see it's putting more output here, and this is building the iOS project.
Nice.
I assume that it might have. Oh no! So now this is where it's stuck now. This is where it's building the iOS framework.
Okay.
And now it's building the Swift app and start. So
okay.
In this setup with the framework we chose, it also just builds. You can show this also in a second. Just builds the configuration you're starting. So if you're building it for the simulator, it just builds the framework for the simulator and runs the app.
Okay.
If you build it for the device, it builds it just for the device.
Yeah.
And runs
I mean, during development, you don't want to build it for like 20 platforms.
For the release, you need to do a bit different things to have like all different. I mean, nowadays it's easier because it's all the same, basically. But still, there are ways to bundle it in a different way to create a XC framework. It's called then to support all different architectures. Yeah, and there it says hello iOS 16.4.
Nice.
So instead of Android, it shows iOS. And so I didn't even need an Xcode. I just had to open it once to install the all the stuff. But if you say, but I want to develop on the iOS app and I don't want to do it like in here
in Android Studio,
this
no code support
thing, you can easily just go to the Xcode project, right click, open in an Xcode, or double click it in the files or so whatever you want, and then it opens up here. And then you have a good ID. No, both are fine
with small font.
Yeah, can increase it maybe a little bit. Where was that? Somewhere they added that.
Is it not working with Control Plus also?
Not for the menu here.
Okay.
Maybe themes. No. I forgot where it was. That like no. It's like a drop down navigator size large. So that's large. As large as it gets. You can also get small. Then this is small.
Okay.
And large.
Good that you told me, otherwise I wouldn't have noticed.
Yeah.
But it's better than nothing.
Okay, but here it's small again, and this one you cannot increase.
Nice.
So what you I can do here, is it already? Yeah, it's already selected. Here I can natively then switch the simulator as I want. Press the run button. I guess I picked now one that is not have not started before, so it may take a bit to launch. But it was now super fast because it used the same built below it, and it has cached the ice project and also the Gradle part already.
Nice.
So it's not fair to compare it that way.
Yeah.
Let's wait for it to start up.
But it's cool. I mean, you would expect it that if you don't change the shared part, that it reuses it and doesn't have to recompile it.
And also, it's not recompiling everything if you change a small bit. So it just needs to recompile what changed. And so now I started it in that simulator with Xcode. And so if you're an iOS developer and the shared part is already there and you just use it in your UI, you can just normally use Xcode. And also with this setup, the great part is if I now change something, we can do it in a second, and then switch back to Xcode and run it here, it also builds it, the shared layer, and does everything.
So you could even mix it and have Android Studio for the shared part, and
you would do that, because then you have both
IDEs that are perfectly matched to what you do.
Exactly. And how this works, so the project has a run script phase when it's building, before it's compiling the sources. It is running this Gradle task, and this embeds and signs the Apple framework for Xcode, as it says. So you don't need to copy a framework around or something. So it compiles it and moves it into the folder, basically, where the derived data is called, where the build artifacts are kept.
Nice.
And then there's like 2 more settings here. You need to tell it the framework search path. You need to tell it where to find the compiled framework, or where to look for it. And it's
okay.
So that's how it works. So it's moving, it's compiling it into build in the build folder in Xcode frameworks.
Okay.
And then debug or release and how it's named. And you just say, if you look for a framework, look here. And the other was the other linker flags, and they specify there's a framework called shared.
Okay.
And if you rename it from shared to something else, you would need to change it here.
But by default, it would already work. It's just if you change something, then
and that's it. That's all that is custom from a normal Xcode project. So if you don't like this project setup and want to have your template or whatever, you can just create a new project. You need to add this run phase and these 2 settings, and that's it.
Nice. It's really, really disconnected.
Yeah,
exactly. It's
cool. Okay. So maybe if we're here right now, let's quickly check how this is used. So this import shared, you already see it's not an iOS framework because it's lowercase s. It's super uncommon to have have it like this. It's a bit strange, but it works. And you use it like a normal Swift class. So under the hood, it's Objective-C. So that's why you will not get structs, for example.
Okay.
The value types of Swift, you will not get. It's always a class. If you have a data class, which would be nice to be mapped to a struct, you have a class. Okay. But yeah, so you have the maybe if I do this and look here, maybe let's switch quickly back to here, because first show how it's set up and then how it's called, maybe the better way. So you have already seen maybe in the iOS project, you have this greeting class.
Okay.
So just a normal class, Kotlin class, living in this common main area. It has one function called greet, which returns a string, and it returns hello, and then uses the
platform object
property that has so local, how's it called on Kotlin correctly?
A val.
A val, yeah.
Yeah, and the attribute of the class.
Yeah. Private attribute, platform, and the name of that. And where does it get the platform from? So first, what is platform? It's defined here, platform. And there's a function get platform. Okay. If I check the platform, KT, this platform is an interface, which defines it should have a name. and it defines a function. I guess it's also called global function in Kotlin, so you don't need a class to call it.
Yeah.
Just can just call it, and so it returns any platform. The interesting part here is this expect keyword in the front.
Yeah,
this means
that's new.
Yeah, that's new. This means you don't provide the actual implementation at this point. You just expect that an implementation will be there when compiling. And the compiler makes sure that for all different
expects,
for expects, there is a matching counterpart for all the different platforms you're compiling. And if I now go into the iOS part, for example, and you see it has a matching file name. I'm not sure if this is required. Maybe I haven't tried to rename it here, but I don't think so. It's like it just checks that there's this function. So where it is doesn't really matter.
Probably the package is important.
Yes.
But this one is. Since it's not in a class, the file name is probably not important.
Yeah. In this case, because it's like this
but
global function.
It's good. It's a good thing to name it the same, so you find it.
Yeah. And here you see this fun get platform again.
Yeah.
This time with an implementation and the actual keyword.
Nice.
So to every expect has a matching actual. And then depending on what platform you're running on, the compiler is choosing one
or the other. Nice.
And puts the implementation then basically in place depending what you compiled.
So in common main, you just define interface. This is what I need, and the iOS main or Android main, they will have to provide this implementation.
But only for those where you really need platform specific stuff.
Yeah, the rest you would directly implement.
The rest, like the greeting, it's just normal,
business logic, normal code.
Yeah, and also in here you don't see any expect. You just use it normally, like calling this function. And so in this example, they chose to have this interface platform and make a class iOS platform, and implement the name. And here you see it is using this UI device dependency. Now, how's that called? Package.
Yeah.
Which gives you the UIKit APIs.
Nice. So you can use in the main stuff, you can use the UIKit APIs.
In iOS main, exactly. You can use the iOS SDKs.
Yeah, nice.
And so I guess you could try to do Bluetooth here.
Yeah.
But so I haven't tried it, but I don't think it's a good idea.
Yeah.
Yes, and then you use functions from here. So you have also like full code completion.
Yeah.
See what it offers, and we did that. And so here it picks the system name, which is iOS then, and then of the current device, the system version. Same here, device system name is iOS, and version is the current iOS version it's running on. And if we look at the Android part, there it's the same thing, actual, then get platform, and this time it returns the Android platform, and there looks like there's no API to get Android out of Android. It's just a string there.
Well, Android is Android. It doesn't matter if it's on a some kind of PC, tablet, or whatever. It's still Android.
I guess it would also return iOS. I'm not sure if it would return iPad OS on an iPad. I don't know.
Mac OS?
Yeah, but then it's like not iOS. Then you have another target for that.
Yeah, but the UIKit still also works on.
Yeah, UIKit is more for iOS. But yeah.
Okay.
Anyway.
Yeah.
This here is the Android APIs.
Yeah.
Thing to get it. So you can also normally use it here, but just in Android main. So you could not use that in common main.
Yeah. Okay, this was quite some deep dive into the project structure, I would say.
Yeah. Before that, I quickly want to wrap this up, make a quick change.
Okay.
So it's a bit stupid, but it's what they also have in their example. I want to have the platform name reversed.
Reversed?
Yeah. So and now instead of going like in here and reverse it here and reverse it here, I don't care about the actual implementation on the platform. I just go in this one thing where I use it.
Yeah.
And put here the reversed function, which flips the string around basically.
Yeah.
And now I changed that. And to show that it is working, let's switch back to Xcode. Just run again. So I have not touched nothing. Yeah, this because I have already built running. It's now building. It was quite fast, and now I have 461 soy.
Okay, yeah, and on Android the same, I guess.
And Android, if I run it here again, switch that, run it. It's also fast, as you see.
Yeah.
Fast and it's also working.
So it's just to illustrate, you can share the business logic.
Yeah. So the business logic would be flipping it around.
Yeah. And putting hello in front.
Yes, exactly. But that was already there. So now we have this change, and let me. No, I don't want this preview thing. How do I close it? Here it has some greeting view. Don't care much about that right now, but you call it like a normal. Create the class or the function. And on iOS, you create the class or the function. So it's same, and this one looks now the same because Kotlin and Swift are super similar.
Yeah.
But this is how you would call a function on a Swift class. And the last thing before we wrap this part up, or maybe let's check this. If you want to see how it looks like in the generated, it's super ugly. Don't want to work with that. This is Objective-C that comes out of the Kotlin part. Super hard to read and ugly. There's one trick you can do if you go into this shared library to the definition. It creates a Swift interface, which looks much nicer than the Objective-C one. Yes. And it always has this Kotlin types to better match between, I guess, Swift and Kotlin types. Not sure. The interesting part is down here. You have a greeting class that comes out of it with the initializer and the function, the platform protocol, the iOS platform implementation, which is a platform. So it also carries that over.
Yeah.
No Android platform.
Wouldn't make much sense.
And then this
get platform
function, which it creates like, this is a bit weird because it puts it into a class here.
Yeah.
So it would be possible on Swift to just put it outside a class and have it.
Yeah.
In Objective-C, it's not possible.
And because it's generating Objective-C, it has to work around it.
So, and it uses then the file name. That's why it's called platform KT.
Yeah.
If I check here, where was it? I lost it. Yeah, platform KT. Yeah. It's the file name where it lives and uses that as a class.
Okay.
But there's also if you would make this, I think, internal or so, it would not generate.
Yeah, because it's not even visible outside the module.
And I would do that to only make this stuff public that you want to call from the outside. Okay,
that's true.
We can wrap it up here.
Nice.
For this part.
So,
are you already completely wrap up or just a...
No. But that was already quite a deep dive into the structure of Kotlin Multiplatform and how the project setup works, and looks really nice. I really like, or I can understand why an iOS guy likes that it doesn't feel too strange in the iOS project itself. It's not like super invasive. That's
separation
really nice.
Is good, and you can still do the stuff you're used to, and just use it. And there's some stuff that might require some extra work on the iOS side, but we also have found a great solution for that. Yeah,